Hi guys, welcome to Geek Coding Academy. Today we'll see advanced use concept static keyword. Let's see. So in our previous video, we talked about on abstraction, interfaces in depth, and nested and anonymous classes. Today we'll see on what you mean by static keyword in Java. So, okay. So in Java, a static keyword means like a static keyword, which will be used for variables, methods, blocks, and nested classes. So if you make all of these static means it will be for a class level. Means JVM first allocate a memory in a static memory space in RAM only once, and it will be for a class level. So whatever, how many object you created for the class, the same copy will be shared among all the objects. Okay. Suppose if you create a variable as a static, it will be given a memory irrespective of creation of object. Like when you load a class, when you try to load a class and create an object, like before creating an object, the static blocks or static variable or static elements will get a memory first, then the object will get created in the RAM space. So, and these static will be only one copy and it will be shared among all the objects created. Okay. So it defines a class level behavior rather than an instance level. Instance level means like instead of an object level, it will be treated as a class level. Let's explore its various context. So yeah, I already told a static can be applied to variables, methods, blocks, and nested classes. So let's see if I make a variable as a static. Suppose if I make a variable as static, so that variable will be shared among all the object of a class. So, okay, rather than being like suppose if a normal variable means it will be tied belong to a specific object, and if you create any one more object, another the variable will get created and it is initialized with a value, whatever default value. But if I make that variable as a static, only one copy gets created in memory and it will be shared to all the objects of the class. Okay. So when a variable is declared static, it means there is only one copy of that variable in memory, regardless of how many objects you created. Okay. Let's see an example. So I created one class here, my class, and I created one variable called a static variable, which is of type integer, and I made this as a static. Okay. And I created one more normal variable like an instance variable, which is of type integer. Okay, this is a normal class variables, and which we called as a non-static variables are generally called as an instance variables. Instance means an object, like it may called as an object variables also. Okay, and I created a one method here inside the class as an increment. This method is simple, like body of the method is simple. It will increment both these variables. Like a static variable plus plus means it will increment it with one, and instance variable plus plus means like it will increment this instance variable with one. Okay, let's come to our main class where it consists of main method. Here I'm creating in a two instance of a my class. That means two objects of my class, object one and object two. Okay. So after that, I'm calling using an object one. I'm calling this method increment method, and I'm printing the values of both static variable and instance variable. Again, I'm using an object two. I'm calling the same method increment method present in an object two, and I'm printing both a static variable and instance variable. Like what will be the output, guys? So in our case, like at the first system.println, I'm pointing object one dot increment. So what it will do is it will increment these two values. Okay, static variable which is of static and it will be class level. So this only one copy will be there for static variable. It will be shared among these two objects, only one. So what happened, like object one dot increment, it will increment firstly, it will increment both these values. Like static variable also become one and instance variables also become one. So when you print it, you can see like static variable one and instance variable one. And this instance variable belongs to this object one instance variable. Okay. So when you do object 2 dot increment, object 2 dot increment, so now it will increment the static variable. So the static variable already one is there because object one has incremented it. So object 2 dot increment, static variable becomes 2, but instance variable becomes 1 only because instance variable belong to an object. So how many object you created, that many copy of instance variables gets created, but static variable only one copy. Okay. So at the end of this system.println, you can see the static variable will be having 2 and instance variable will be having 1 only. Okay, this is all about static variables. Let's see now static methods. Okay, so static methods, similarly, first how static variables, static methods also, if you made any method as static, it belongs to a class rather than the object. Okay, and this will be, we can able to call this without creating an object, because it, like JVM will first, like how the control flow will work is JVM first it will check for static members, like any static variables is there, static methods is there, static blocks is there, that will get a memory first, then it will create an object. Okay, so like there are some restriction if you use the static methods, because what restriction we have is, like if you make any method as static, that method if it's referencing any, so it can only refer to the static members or static variables of that class, not a non-static. Why? Because like I already told, static methods will get memory first. So how can it will be accessed non-static variables? Non-static variables will get memory only after creating of an object. So that's the reason, like we have some restriction. If you make our method as a static, static methods can directly call other static methods, or it can access static variables, but they cannot access non-static variables or non-static methods directly. Okay, and cannot use this or super. I already told in my previous video, like in Java, this refers to the child object or current object which we are in, and super refers to its parent object. Okay, here in static method there is no question of objects, right? It will be class level. So since static methods does not belong to any object, there is no concept of this or super, or we cannot reference this or super here. For example, I created a class called calculator, and I've added one method add. It is just a normal uh, sum of a plus b, and which will return of type integer, like value will be returned int. And I made this method as a static, so this will get memory irrespective of an object creation. So in a main class under main method, I can able to call directly. You can see here using a class name calculator dot add 510. I can pause. Like normal methods, we have to create an object using a new operator. We need to create an object. Then with the help of object reference, we need to call that method. But this is a static method. So directly using in a class name, using dot operator, I can able to address this method name like dot add, and I can pass the variables, and it will return a result. Okay, I can able to print the result up here. Okay, 5 plus 10 is 15. I get an output as 15. Okay, let's see what it mean by next. Let's see what is static blocks. Okay, static blocks. Why we use static blocks is, like I already told, like when we create any class variables, okay, any non-static variables, at the time of creation of object, we have a constructor. Constructor get called before creating an object. So in constructor, we will initialize the non-static variables, okay, in terms of normal variables. But in case of a static variables, okay, in case of static variables, like even before constructor, that gets memory. So if you want to initialize a static variable, we can make use of these static blocks. Okay. So even before constructor, the static blocks gets called. So a static block is means like there will be a set of instruction that's get executed when a class is loaded into memory and before any objects are created. Okay. Use case for this is static blocks are often used for initializing a static variables that required some complex like suppose if you have some complex logic to initialize a static variable, we can make use of these static blocks. Okay. This is also for a class level. For example, you can see here I created one class called static block example, and I created two variables, num and message, which is of type int and string respectively. And both these variables I made it as a static. So these are all static variables. And these static variables I have not initialized here. Okay. So if I not initialize, it will be initialized with the default values, but I don't want default values. I want some values to be initialized for them. So what I'll do is I'll create one static block. Static block is just a set of instruction here, like and there is no name, nothing. Just we can give like a static and a set of instruction where I'm giving an 100 and message allow from static block. Okay, I'm just initializing my static variables using a static block. For non-static or in normal variables, we will initialize using a constructor, right? Similar way, for a static variables, we can initialize using a static block. And a main method, in our main method, we can call the static variables, like using a class name, we can access the static variables or static methods. I already told, like static block example dot num and static block example dot message. It will print accordingly the unread and allow from a static block respectively. So let's see the last type of use case for a static keyword is static classes, that is nested class. In our previous video, we talked more on anonymous and nested classes. If you can also go and watch, but here I'll briefly tell what I mean by nested class. Nested class means a class defined inside of another class. Okay, the which where the class is, we set it as a static. Okay, so a static nested class can exist like from within another class. Unlike regular inner classes, a static nested does not have any access to. And also the, like I already told, like we create a one class inside of another class, and we made that nested class as a static, that becomes static nested class. And the static nested class will only access to static variable of that outer class. Okay, because wherever you go, like if you want to create, if you're creating any static, it will only access static, because at the time of class is loaded, these, well, these statics members will get memory. So whereas how can they access non-static if that doesn't exist, right? That's a common logic. Like that's why the static will only access static variables. They can't access the normal object variables. Okay, use cases is static nested class are used to group classes that are only used within the context of the outer class. Like in outer class only we are using. Suppose we have an outer class inside, we have this static nested class, and those context is only limited to that outer class. We have to use this static nested class, and don't need a reference to the outer class instance. Okay, let's see an example so that you will get understand. So I created one class called an outer class. Like inside this class, I created another class called a static nested class, which is why it's static, because I made it as a static. I created one more class as static nested class, and I appended it with a static keyword. So it becomes a static nested class. So inside this, I created a display, one method called display, where I'm just displaying I am from static nested class. So in my main method under main class under main method, so you can see here, I just created a object for my outer class, new of outer class, and it will provide me an instance. Only I'm creating an object for my outer class, but I'm not need to create an object for a nested static class, because it's already get memory when class is loaded. So I'm just calling with a dot point operator. I'm just calling it the class name. So the object, only one object gets created in the memory, right? That will be passed to me, and using that I'm printing this method. So inside a static nested class. Okay. Okay. There is a one more type called, yeah, sorry. There is a one more type called in static import. So you guys already know, like what I mean by import is, suppose in our Java, like in our class, we want to use some of the functionality which are already defined in another class. We can import that class. So if you import that class, so all the functionalities available in that class, we will able to use in our current working class. Okay. So that is what called an import. Like what I mean by static import is, we don't have to actually create a object for that. Like if you do a static import, all static, very static members, like even static methods or static fields, we can directly use in our class. Okay, static import allows you to import a static members, the static like fields and methods of other class, that you can use them without qualifying with the class name. Like we don't have to give a class name, just we can use it. Suppose like if you see an example, I'm just importing a static java.lang.math. So math class is given by Java under language package, sorry, lang package. I'm doing here an import dot static import I'm doing here. So what it will do is, like in my main class under my method, I'm just calling the method sqrt, square root method is defined in math class, and it is a static method. I'm just directly calling this method. Okay, if I don't do any static import, I have to call like a math.sqrt. Using in class name, I need to define. But if I do a static import, directly I call the methods without qualifying the class name. Okay. Instead of math.sqrt, I'm just directly I can call it in sqrt. Instead of math.py, similarly for this field also, the py is a static variable. present in a math class. Instead of math.y, I can simply call as an pi. So let's see the key points to remember. Okay, static members are shared. Like a static variable is shared among all the objects of a class, and a static method can be called without creating an object. Okay, and connect access a instance variable means static methods cannot directly access the non-static variables or methods. Why? Because we already know, because these gets memory first, and non-static variables we get to memory later. So there is no existence at the time of creation of the static methods in memory. There is no existence of non-static methods, so it can't able to access that. And it's class level initialization. So static blocks are used to initialize static variables and are executed when a class first loaded into memory. Okay. So let's code. So these are all about theory. If you see about the working code, you will be more clear. Yeah. So guys, I created one class called static keyword demo. Here I combined all the examples in a single class. And yeah, first I imported a java.lang.math as a static import. So if I do a static import, I don't have to specify a class name for calling any method or variable. And I created one class called a class combined example because I combined all the examples. I created one static variable which is of type int, and it is a static. And I created a normal variable or an instance variable, just instance var, and it's a int. I just initialize both of them with 0. And I use the static block where I'm just printing static blocks. I already told is to initialize a static variable. I'm just printing it is executed from static block, and initially I initialized static variable with 0. Now I'm initializing it with 100. Okay. So after that, I created one method inside this combined example class as an increment method, where it just increment both static variable and instance variable, just to want to show like how static variable will be shared among all objects and how instance variable will be created for particular object wise. And I created one more method. It's a static method for a display static where like it's static variable, it's accessing in a, see here, I created a static method here, and static method can only access the static variable. It can't access non-static variable. Okay. And created one more static nested class. I created a method over inside of a nested class where I just print this inside static nested class. Okay. So this is my main method, static keyword demo. This is my main class, and this is my main method where I'm just first I'm just printing the static variable, because with static variable without creating of an object we can able to call the static variables using a class name. So combined example dot static var. So initial state of any static variable I get it, and after that I just created two objects, object and object two. I just call the same increment method, so it will increment both static variables and an instance variables. Later I'll print these both, static var and instance var, static var and instance var. Let's see like what it will be, like how the values got changed. After that I'm planning I'm planning to call a static method using any class name. Here up to this level, like I'm not created any object, like even I created object for only to access this instance variables. Like for this method, just I'm using a class name to call this method because it is a static method. I'm just printing, see, I'm just printing a square root and pi directly, sqrt and py. I'm not calling here math.sqrt or math.py because I'm using a static import. So, and also for a nested class, I'm just created an object of an outer class, but I've not created an object for the inside class. Just I'm calling the static nested class directly using the dot pointer. Okay, because it is a static class, static nested class, and I'm printing the method which I returned inside this static class display method. Okay, let's run the program. So as you can see, static block gets executed. Okay, at this point static block get executed. So static block executed, and it make the static variable as 100. So initial state of a static variable is 100 here. So two objects are created, object 1 and object 2. The static variable becomes 100. It will be like I'm just printing up here, like why it is, it's just printed up here. You can see here, both I'm doing an increment at the time. Okay, that's why you can see here. like 102 means like both object 1 dot increment and object 2 dot increment. Both I'm just incrementing here. So 100 becomes 101 in first case, object 1 dot increment. And in second case, 101 becomes 102. So 101, 102, 102. But instance variable is 1 only. Why? Because uh, every time it will, like initially instance variable is 0 when the object gets created. Because even in constructor also, I'm not initializing them with any other value. The default value for the int is 0. So once I do an increment, instance variable will get 1, and object to dot instance variable. This is object to instance variable, that is also 1. Okay. The static variable now it becomes 1 or 2. The square root of 16 is 4, and value of y is 5. This is we got from the static import. And inside a nested static class, which will be called from this display. For this example, what I'll do is I'll just do some modification. I'll print up here so that you can get a complete picture. Yeah. Now if I run this, yeah, you can see here initially static variable is 100 because we initialized them in a static block. For object 1, it incremented it with 101, but it instance result 1 only. For object 2, it incremented the static variable to 102, and its instance variable is 1 only. Okay, you guys can understand now. Like the static variable will be shared among all the objects, but instance variable are like object specific. If you create one object, automatically the new instance variable gets created in memory. Okay, so these are all about complete static keyword where we are used. Okay, guys, like brief summary means like in static. We use static for variables, methods, nested classes, and blocks and imports. Like 5 places we use the static keyword in Java. The static means we want to make them as a class related, a class level. We don't want to tightly tie them with an object, and this gets memory when a class is loaded. So even before calling the constructor, even before calling of a constructor, this gets memory. So these are about static keyword and static things in Java. In my next video, I'll talk about on final. That is also a keyword. What do you mean by final keyword? I'll talk about on that. So thank you for watching. Till like if you like the video, please share this video to your friends and colleagues. Please subscribe to my channel. So I'll meet you in the next video. Till then, keep watching, keep learning. Thank you. Bye.